All right, so earlier we talked about function notations and how to take a function notation or take a number that will be inside the parenthesis and how to substitute it into an expression. Well, we're looking at, or our example is if p of x is equal to x squared plus x plus 4 and q of x is equal to 9x squared minus 4, find p of 7 and find q of negative 9. So remember, functions are given different names. So our first equation, it says here, find p of 7. Well, we have two functions, p of x and p of q. Okay, where are we going to substitute this p of 7 in for which equation? The p of x equation. X squared plus x plus 4. So wherever we see x, we're going to plug in the variable 7. The number 7 in for the variable. And let's square 7. We have 7 times 7, which is 49, plus 7 plus 4. And 49 plus 7 gives us 56. And 56 plus 4, we have 60. Our next example, it says find q of negative 9. So we're going to substitute 9 into this expression. 9x squared, 9 times x squared minus 4. What's being raised to the second power is the 9. It's the x here. In turn will be negative 9. So we have 9 times negative 9 squared minus 4. Let's square negative 9. That's 81. And 9 times 81, we have 729. And we're going to take away 4. And we have 725. There we go. So now let's get into adding and subtracting with polynomials. Now this is nothing new with the adding and subtracting as far as us talking about and covering, going over and talking about the terms, talking about like terms. So let me just talk about something that you did before. You were given something such as 3x plus 5x. Now, when we talk about um, terms versus factors, when do we add, when do we not add, or anything like that? Now, since we're adding, these are terms. Actually, this is a binomial. We're going to add the 3 and 5. These are like terms. That would give us 8, and we keep the common variable. See, like terms, we do not change the variable, but we work with the coefficients. So in this section, what's going to make this section different than what you've done previously, now you're going to have something such as 3x squared y cubed plus 5x squared y cubed. Because there's a plus sign here again, these are like terms. We just add 3 and 5 and we keep the common variable. When we multiply, when do we multiply exponents? When do we add exponents? Well, we add exponents when we are multiplying. We're not multiplying in this question. Okay, so just want to just do a little recap of something that you've completed before. So adding with polynomials. Here we have 8y squared plus y minus 5 plus 5y squared minus y minus 6. When you're adding polynomials, there's a plus sign between the two trinomials. It says drop the parentheses. And we're going to do that. Combine like terms. Recall that like terms have the same variable raised to the same power. So we have 8y squared and 5y squared. We're going to add those together. We have positive y and minus y. And then we have minus 5 and minus 6. So then once we combine the like terms, add the coefficients. So 8 plus 5 for our y squared, we have 13y squared. Our y's, they're going to cancel out because y minus y would give us 0. And then negative 5 minus 6, we have here minus 11. Now, the next example for subtraction. Addition is really easy. It is what it is and everything. All we're going to do is just drop the parentheses. Now, next, subtraction with polynomials. Here's an example. Make that 2. We have 8y squared minus 7y plus 9 minus 2y squared minus 7y plus 3. With subtraction, anytime that there's a minus sign in front of a parenthesis, you have to distribute the subtraction sign. So since we have a trinomial after this minus sign, we're going to distribute that negative. Bring down the first set of terms that's in the first parenthesis. Distribute the negative. We have negative 2y squared, positive 7y, and minus 3. Once we distribute the minus sign, then we combine our like terms. Add your y or subtract your y squareds. We have 8 minus 2, that is 6y squared. And then we have negative 7 plus 7, that's going to cancel out. And we have 9 minus 3, which gives us 6. Let's do another subtraction. We have here 5x squared plus 3x plus 5 minus 3x squared minus 7. What's being subtracted is the 3x squared minus 7, so we're going to distribute that negative. Bring down the 5x squared plus 3x plus 5, and then we're going to have minus 3x squared plus 7. Then we're going to combine our like terms. Our x squareds, our x, and then our real numbers. So we have here our x squareds. We have 5x squared minus 3x squared, which gives us 2x squared. Bring down the 3x. We don't have anything to add or subtract to it, but it's part of the question. And then we're going to add 5 and 7. And 5 plus 7 gives us 12. Now, we cannot bring these terms together. We have 3 different terms. We are finished with this. With this example, 2x squared plus 3x plus 12.